Hello dear students, in last lecture we studied definition of system of linear equations in n variables. Then we study system of non-homogeneous equations and homogeneous equation and some its properties, and how to write system of equations in matrix form Ax is equal to b. In today's lecture we solve some problems of non-homogeneous equations. So we start with system of equations. System of linear equations and system of m linear equations in n variables say x1, x2, x3 up to so on xn as follows. a11 x1 plus a12 x2 plus a13 x3 plus up to so on plus a1n xn is equal to b1. a21 x1 plus a22 x2 plus a23 x3 plus up to so on plus a2n xn is equal to b2. a31 x1 plus a32 x2 plus a33 x3 plus up to so on plus a3n xn is equal to b3 and so on. Last equation is am1 x1 plus am2 x2 plus am3 x3 plus up to so on plus amn xn is equal to bm. This is a system of m linear equations in n variables where aij and bi are constants, may be real or complex. aij is equal to a is an element in ith row and jth column. The above system is said to be non-homogeneous system of linear equations. If all bi equal to 0, that is b1 is equal to b2 is equal to b3 is equal to up to so on is equal to bm is equal to 0, then given system is said to be homogeneous system of linear equations. The above system of equations written in matrix form as follows. A11 matrix A11 A12 A13 up to so on A1n A21 A22 A23 up to so on A2n and so on. Last row is AM1 AM2 AM3 up to so on AMN. This is a matrix of order m by n into matrix x1 x2 up to so on xn is a column matrix of variables or unknowns of order n by 1 is equal to matrix b1 b2 up to so on bm of order m by 1. The first matrix is known as coefficient matrix. Second matrix, the column matrix, this column matrix is known as unknown or variable matrix. And equal sign matrix b1 b2 up to so on bm, this is column matrix of order m by 1 is known as constant or solution matrix. Simply it is written as AX is equal to B. Examples: and solution of non-homogeneous equation system of equations. First, solve following system of equations. Following system of non-homogeneous equations. First equation is x x1 plus x2 plus x3 equal to 2. 6x 1 minus 4x2 plus 5x3 equal to 31. 5x1 plus 2x2 plus 2x3 is equal to 13. This is system of non-homogeneous equation in 3 variables. Solution: तर ही दिलेली सिस्टम ऑफ इक्वेशन आहे 3 व्हेरिएबल मधली. 3 अननोन आहे x1 x2 आणि x3 आपल्याला फाइंड आउट करायचे. तर आपण हायस्कूल मध्ये शिकलेलो आहे. ओके, we have x1 plus x2 plus x3 is equal to 2. This is equation first. 6x1 minus 4x2 plus 5x3 is equal to 31. Equation second. 5x1 plus 2x2 plus 2x3 is equal to 13. Equation 3. Now our target is to find x1, x2 and x3. आपलं काय टार्गेट काय किंवा आपलं ध्येय काय, x1, x2 आणि x3 जे आहे त्याची आपल्याला व्हॅल्यू फाइंड आउट करायची आहे. आपण काय करणार आहे तर ही इक्वेशन सॉल्व करणार आहे एकमेकांचा उपयोग करून. तर आपण पहिल्यांदा घेऊ, आपण काय करू, x1 रिड्यूस करू दोन इक्वेशन मधल्या. First, we eliminate x1 from equations 2 and 3 by using equation 1. ओके, इक्वेशन 1 चा उपयोग करून आपल्याला इक्वेशन 2 आणि 3 मधला x1 काढायचा आहे. ओके, to eliminate x1 from equation 2, we multiply equation 1 by -6. पहा आपल्याला एलिमिनेट काय करायचं आहे, x1 करायचा इक्वेशन 2 मधला, म्हणजे आपल्याला हा एलिमेंट करायचा 6x1. तर हा कसा एलिमेंट होईल, हा कसा एलिमेंट करता येईल, म्हणजे हा काढता येईल. तर ह्याच्या ऑपोजिट टर्म इथं पाहिजे, म्हणजे इथं काय पाहिजे -6x1. जर यांची ॲडिशन केली तर -6x1 आणि +6x1 काय होईल, कॅन्सल होईल, 0 होईल. त्याच्यामुळे आपल्याला त्याला इक्वेशन 1 ला -6 ने मल्टिप्लाय करावं लागेल. ठीक आहे, तर असं केल्यानंतर आपल्याला एक नवीन इक्वेशन मिळेल. we get -6x1 -6x2 -6x3 is equal to -12. This is equation 4. Adding equation 2 and 4 we get, ठीक आहे, आपल्याला इक्वेशन 2 आणि 4 चे काय करायचे, ऍडिशन करायचे. तर काय मिळणार आपल्याला 6x1 minus 4x2 plus 5x3 is equal to 31 plus -6x1 -6x2 -6x3 is equal to -12. ठीक है, दिस इज इक्वल टू याचं सोल्युशन काय येईल तर 6x1 मायनस 6x1 हे कॅन्सल राहिले काय मायनस 10x2 मायनस x3 इज इक्वल टू 31 minus 12 19. Okay. This is equation 5. Therefore minus 10x2 minus x3 is equal to 19. This is equation 5. Okay. To eliminate x2 x1 from equation 3 we multiply equation 1 by आता आपल्याला इक्वेशन 3 मधला x1 एलिमिनेट करायचा आहे म्हणजे आपल्याला हा 5x1 एलिमिनेट करायचा आहे आपल्याला इथं किती मल्टिप्लाय करावं लागेल हा -5 ने बरोबर एकदम बरोबर ठीक आहे आपल्याला -5 ने मल्टिप्लाय करावं लागेल त्यास आपल्याला काय मिळेल ते इक्वेशन मिळेल की जे आपल्याला लागते ते ओके we get -5x1 -5x2 minus 5x3 is equal to minus 10. This is equation 6. Adding equation 3 and 6 we get equation 3 is 5x1 plus 2x2 plus 2x3 equal to 13 plus minus 5x1 minus 5x2 minus 5x3 is equal to minus 10. This is equal to what we get? We get this 5x1 cancel. We get minus 3x2 minus 3x3 is equal to 3. Therefore we get minus x2 minus x3 is equal to 1. This is equation 7. After eliminating x1 from equation 2 and 3 we get new system of equation. New system of equation is equations is or equations are as below. First equation is same, that is x1 plus x2 plus x3 is equal to 2. This is equation 1. Next equation is what we get? Equation 6. Equation 5. Minus 10x2 minus x3 minus 10x2 minus x3 equal to 19 equation 5 and minus 3x3 minus x2 minus x2 minus x3 is equal to 1. This is equation 7. We get this new system of equation. ओके, तर आपल्याला नवीन सिस्टम ऑफ इक्वेशन मिळालेली. तर आपलं टार्गेट काय आता, आपल्याला x2 रिमूव्ह करायचा आहे. काय रिमूव्ह करायचा आहे? x2. Now we eliminate x2 from equation 7 by using equation 5. ओके, इक्वेशन 5 चा यूज करून आपल्याला इक्वेशन 7 मधला x2 रिमूव्ह करायचा आहे. तर कसं करता येईल, तर मल्टिप्लाय इक्वेशन 7 by minus 10 we get. काय मिळेल तुम्हाला, इक्वेशन 7 ला मायनस 10 ने मल्टिप्लाय करायचं आहे. काय मिळतं मग, तर 10x2 plus 10x3 is equal to minus 10. This is equation 8. Adding equation 5 and 8 we get what we get? We get equation 5 is minus 10x2 minus x3 is equal to 19 plus 10x2 plus 10x3 minus 10 we get minus 10x2 plus 10x2 cancel, we get 9x3 9x3 is equal to 9. Okay, what we get? We get one equation hence we get 9x3 is equal to 9. This implies that x3 is equal to 9 upon 9. This implies that x3 is equal to 1. That is, we get value of x3 is 1. By back substitution, we get values of x2 and x1. Put x3 is equal to 1 in equation, which equation? तर आपल्याला x3 ची व्हॅल्यू यूज करते ना, असं कोणते इक्वेशन आहे, तर आपल्याला यूज करू शकतो आपण कोणते इक्वेशन? इक्वेशन 5. ओके, इक्वेशन 5. Put x3 is equal to 1 in equation 5. Put x3 is equal to 1 in equation 5. Minus 10x2 minus x3 is equal to 19. This implies that minus 10x2 minus 1 is equal to 19. This implies that minus 10x2 is equal to 19 plus 1. This implies that minus 10x2 is equal to 20. Therefore x2 is equal to 20 upon minus 10. We get x2 is equal to, therefore we get x2 is equal to minus 2. This is the value of x2 is equal to minus 2. Put x2 is equal to minus 2 and x3 is equal to 1 in equation 1. What is equation 1? x1 plus x2 plus x3 is equal to 2. Therefore x1 minus 2 plus 1 is equal to 2. x1 minus 1 is equal to 2. x1 is equal to 3. Hence, required solution of given system of equation is x1 is equal to 3, x2 is equal to minus 2 and x3 is equal to 1. This is the solution. Check. How you check the solution is correct or not? आपलं सोल्युशन बरोबर आहे का नाही ते कसं चेक करणार आहे आपण? चेक. Consider any equation. Consider LHS of equation 1. LHS x1 plus x2 plus x3 is equal to 3 minus 2 plus 1 is equal to loop, which is equal to RHS. Therefore the given system is given solution is correct. Okay, so dear student, we solve one non-homogeneous system of equation and get a solution. तर विद्यार्थी मित्रांनो, आपण एक नॉन होमोजेनियस सिस्टम ऑफ इक्वेशन घेतलंय आणि त्याचं सोल्युशन कसं काढायचं हे पूर्ण स्टेप वाईज पाहिलेलं आहे. तरी लेंथी प्रोसेस आहे, याच्यापेक्षा सिंपल प्रोसिजर आहे, पण ते आपण आता पुढच्या लेक्चरमध्ये पाहू. तर सोल्युशन ऑफ इक्वेशन काय असतं तर ते तुम्हाला कळालं असेल. जर कोणाला काही डाऊट असेल तर मला तुम्ही विचारू शकता. ठीक आहे, ओके. तर पहा, मी तुम्हाला एक व्हिडिओ दाखवतो, त्यात तुम्हाला सोल्युशन कसं काढायचं ते समजेल. ओके, तर एक्झाम्पल सॉल्विंग अ सिस्टम ऑफ 3 इक्वेशन्स इन 3 व्हेरिएबल्स बाय इलिमिनेशन. आता आपण पाहिलं एक इक्वेशन आपण घेतलेलं काय एक्झाम्पल. ओके, आपण जे सोडवलंय तेच तसं पहा. काय सोल्युशन? 3 minus 2 and 1. करेक्ट आहे? 3 minus 2 and 1. This is the solution. तर पहा, आपण जे डिटरमाइन वेदर द ऑर्डर इज अ सोल्युशन ऑफ द सिस्टम. तर आपण आता हे सोल्युशन आपण चेक केलं. पहा, ओके, हे सोल्युशन आपण चेक केल्याचं. सोल्युशन कसं चेक करतात तर त्या व्हॅल्यू त्यात टाकल्या का ते काय झालं पाहिजे? सॅटिस्फाय झालं पाहिजे. तर नाही तर जर सॅटिस्फाय केलं तर त्याचे काय ते सोल्युशन आहे. ठीक आहे, ओके. Solve the system minus 2x minus y minus 4z is equal to 1, minus 4x plus y plus 5z is equal to minus 28, and Last equation is 8x plus y minus 3z is equal to 44. We have to find the values of x, y, z. आपल्याला x काय करायचं आहे, अननोनची व्हॅल्यू काढायची आहे. तर 3 व्हेरिएबल दिलेले आहे x, y आणि z. तर ते कसे फाइंड आउट करायचे आणि सोल्युशन म्हणजे काय ते आपण डिटेल एक व्हिडिओमध्ये पाहू शकतो.
that would satisfy all three equations. And when solving a system like this, there are actually three possibilities. We can have one solution, no solution, or an infinite number of solutions. So before we solve this, to get a better understanding of this, if we graph these in space, each of these would be a plane. So if we graph three planes in space, there are three possibilities. As we see here, the planes could intersect in one point, which means the system would have one solution. So we can say the system is consistent and independent. We say consistent because it has a solution, and independent because it has one solution. But it's also possible, if we graph three planes in space, there aren't any points that are on all three planes. Therefore, the system would have no solutions, and we can say the system is inconsistent. The third possibility is there are an infinite number of points on all three planes. As we see here, notice the three planes intersect in this yellow line, and there's an infinite number of points on a line, therefore we have an infinite number of solutions. So we can say the system is consistent and dependent. Again, consistent because it has a solution, and dependent because it has an infinite number of solutions. So before we solve our system, let's review the elimination method. The first step is to select any two equations and eliminate any one of the variables from the two equations. Then we'll select two other equations and eliminate the same variable again. This will give us two equations with two unknowns, which we'll solve using the elimination method and then perform back substitution to solve for all the variables. So for the first step, let's go ahead and label these equations so we can stay organized. Let's call this equation A, equation B, and equation C. We first want to select two equations and eliminate one of the variables. It doesn't matter which equations we select or which variable we want to eliminate. Let's go and select equation B and C and eliminate these z terms. Notice how they're already opposite signs, so if this was plus 4z, we could add the two equations together and eliminate z. So let's go ahead and multiply equation C by 2 and add it to B. So we'll have 2 times equation C plus equation B. 2 times C would be 2x minus 2y plus 4z equals negative 8. We're going to leave equation B the same. And now we'll add the two equations. Notice that the z terms are opposites, therefore this sum would be 0. So we have 4x plus y equals negative 4. We'll use this equation again in just a moment. Now we'll select two other equations, but we do want to eliminate z again. So let's use equation A and equation C. Again, notice how the z terms are opposites. So again, if this was plus 4z and we added the two equations together, the z term would be eliminated. So we're going to multiply equation C by 2 again, but now add it to equation A. So now we'll have 2 times equation C plus equation A. We just multiplied equation C by 2. It was 2x minus 2y plus 4z equals negative 8. We're going to add this to equation A, which is 3x plus y minus 4z equals negative 6. So we'll add these two equations together. Notice how these z terms again are opposites. This would sum to 0. So we have 5x minus y equals negative 14. Notice what we've done now is we've created two equations with two unknowns. So we'll solve this as a system using elimination. So now we want to solve the system 4x plus y equals negative 4, and 5x minus y equals negative 14. Now we kind of lucked out here because notice how the y terms are already opposites. So we can add these two equations together and eliminate y. Sometimes this won't be the case, and we have to multiply one or both of the equations by a constant, so either the x or y terms would be opposites, similar to what we did over here for z. Well, here we can go ahead and add these equations. This would be 0, so we have 9x equals negative 18. Divide both sides by 9. So now we know that the x-coordinate of our solution must be negative 2. Remember, we're not done. We're trying to find the x, y, and z value that satisfy this system. So now we'll perform back substitution to find y and z. To do this, we'll select an equation. To do this, we'll start by finding an equation that has just x and one other variable. So again, to keep organized, let's call this equation D and call this equation E. Notice if we used equation D, we could solve it for y by subtracting 4x on both sides. We can say y is equal to negative 4x minus 4. We can substitute negative 2 for x and solve for y. So y is equal to negative 4 times negative 2 minus 4. This would be positive 8 minus 4. So now we know y is equal to positive 4. Now we still have to find z. To do this, we'll go back to one of the original equations and substitute values for x and y so that we can find z. Let's go ahead and use equation C. So using equation C, now x is negative 2, so we'd have negative 2 minus y, but y is 4, so minus 4 plus 2z must equal negative 4. Well, this would be negative 6 plus 2z equals negative 4. Add 6 to both sides. We have 2z equals positive 2. So z is equal to positive 1. So notice how this system has one solution, meaning that these three planes would intersect in the point where the x-coordinate is negative 2, the y-coordinate is positive 4, and the z-coordinate is positive 1. And in fact, many times you'll see the solution given as an order triple, so we can say the solution is the point negative 2, 4, 1. And we'll go and take a look at this in just a moment. Again, if we graph this in space, we would have three planes, and we're saying that the point of intersection would be this point here. Well, here's the graph of the three planes in space. This point right here is our solution because it's the only point that's on all three planes. Let's go ahead and rotate this to the other side so we can see it again. Again, it would be this point that we see right here, which we found using the elimination method. I hope you found this example helpful. We'll take a look at several more examples in the next few videos.
So, okay, student, we understand the concept of system of equations in three variables and how to solve this system of equation by using elimination method. Okay, student, I hope you understand the concept of system of non-homogeneous equations and how to solve the system of equations in three variables. In next lecture, we discuss homogeneous system of equations and solve more problems on non-homogeneous equation. Okay, thank you.